Welcome back everybody, Patrick here, moving on to another rate of change question. We have to find the instantaneous rate of change of g of x equals 1 over x plus 1 when x is equal to 2 using the difference quotient. Now, this question is fairly tough. Usually when you're given a function like this that's not a polynomial, teachers want you to find the instantaneous rate of change using one of the approximating methods. So the preceding interval, following interval, centered interval. Usually you don't have to find the exact instantaneous rate of change using the difference quotient. However, some teachers will expect you to know how to do so. And it's fairly tough. The algebra is a little bit unique, so that's what we're going to go over in this video. So using the difference quotient, so the instantaneous rate of change at an x value of 2, we know it's what? It's going to be g of 2 plus h minus g of 2 all over h. And what we're going to have to do is we're going to have to simplify this expression and then plug in an h value of 0 at the end. Because as h gets very small as it approaches 0, that's when we get that exact instantaneous rate of change. So g of 2 plus h, what's that going to be? Well, if g of x is equal to 1 over x plus 1, then g of 2 plus h, we're just plugging in 2 plus h for the x. So g of 2 plus h would be 1 over 2 plus h for the x value plus 1. Right? Does that make sense? I took this 2 plus h and I just plugged it in for the x value. And then notice how we can simplify this denominator. 2 plus 1 is 3. We got that h there. So g of 2 plus h is equal to 1 over 3 plus h. And then we're going to be subtracting g of 2. Now g of 2 is going to be what? 1 over 2 plus 1, right? If we plug in 2 for the x value, that would be 1 over 3. So we're going to be subtracting 1 over 3, and this is going to be all over h. So notice at this point we can't sub in an h value of 0 yet because we still have this h in the denominator. We need to get rid of it somehow. Now, whenever we're dealing with polynomial functions, so like let's say x squared plus 2x, and we do this on the side, it's a lot easier to see what we do because the numbers will all cancel out. We'll factor out an h from the remaining expressions, and then the h's cancel out. And then our expression is a lot nicer to simplify. In this case, notice how we're dealing with fractions in the numerator. So it's a lot tougher. So what you want to do is you want to combine these fractions in the numerator into one fraction. So how do we do that? Well, let's do that on the side, just so we're not confused with this h here in the denominator. So how would we simplify, or how would we combine 1 over 3 plus h minus 1 over 3? Well, we have to get a common denominator in order to subtract fractions, so we can multiply these two. So basically we'll have 3 plus h times 3. So notice that this 3 plus h we multiplied by 3. So what we do to the bottom, we have to do to the top. And then this 3 we multiplied by 3 plus h. So again, what we do to the bottom, we have to do to the top. So now, since we have a common denominator for both of these, which is here, we can subtract the numerators. So 1 times 3 is 3, and we're going to be subtracting this whole expression, 3 plus h. And make sure that whatever you're subtracting here, if there are multiple values, you have to put them all in brackets because you're subtracting that whole expression. So distributing this negative inside, 3 minus 3 is 0, then negative 1 times positive h is negative h. So we'll be left with negative h over 3 bracket 3 plus h. Just brought this 3 in front here to make it look a little nicer. So this here is going to simplify to this. So we're going to have negative h over 3 bracket 3 plus h. And then this is still going to be all over that h in the denominator for the difference quotient. All right, so I'm going to erase this here to give myself a little more room. And I'm going to continue this up here. Okay, so notice how we have a fraction in the numerator, and then we're dividing by an expression in the denominator, this h here. Well, let's put this h in the denominator over 1. So it's like we're taking one fraction and dividing it by another fraction. So let's rewrite that up here. So we have negative h over 3 bracket 3 plus h divided by h over 1. Now, what do we do when we're dividing a fraction? Well, we flip that second fraction and then multiply them. So we'd have negative h, 3 bracket 3 plus h, multiplied by 1 over h. Then notice how the h's cancel out, and we're left with negative 1, right? Negative 1 times 1 is negative 1. And then here we're left with 1 in the denominator after we cancel out that h with this one. So 1 times 3 bracket 3 plus h would just give us 3 bracket 3 plus h. So now notice how we can plug in this h value of 0 because we got rid of that h in the denominator. That was by itself, right? We canceled it out here. So now we can plug in 0 for h, right? So as h approaches 0, what's this expression going to approach? Well, it's going to approach negative 1 over 3 bracket 3 plus 0, which is 3. And then that simplifies to negative 1 over 9. And that is your final answer. So that is the instantaneous rate of change for this function, 1 over x plus 1, when x is equal to 2. So a lot more complex. Usually when you're given a function like this, most teachers at this point, you do this more in calculus, they'll want you to find the instantaneous rate of change or approximate it using the centered interval, preceding interval, following interval methods, and you'll get something very close to this. However, there are a couple of teachers where they want you to take reciprocal functions like this and be able to use the difference quotient and algebraically manipulate it, like we did here. So if that was confusing, make sure you rewatch that because depending on your teacher, it may come up on the test. But same thing applies, same intuition. You basically want to get rid of that h in the denominator somehow in order to plug in 0 for h at the end. And then you get that instantaneous rate of change, that exact instantaneous rate of change of negative 1 over 9 for this question.